Hello, I'm David Greenspan from Meteor Development Group, and welcome to my talk, Upgrading Your JavaScript to ES2015. This is a fun talk for me to give today, because everything I'm going to tell you is good news about JavaScript. I'm not on any of the committees, by the way, for JavaScript. I'm just an observer and a lover of JavaScript. I do get to do this stuff at my day job at Meteor, and my coworker Ben Newman is actually on the TC39 committee, which is the JavaScript standards group. So I've been writing JavaScript since 2007. I like to create these really rich client apps that are very demanding on the browser. I like to create frameworks. And in 2007, the browser that I always had to imagine running my code was Internet Explorer 6, which at the time was by far the most popular browser, also the least standards compliant. This was before Chrome, by the way. The browsers we had were Firefox 1.5, Safari 2. And I kept running my code through Internet Explorer 6 in my head, also in testing, until about 2013, when Meteor dropped support for Internet Explorer 6. As web developers, we have to care about the lowest common denominator for compatibility reasons. And at Meteor, we care about the browsers that our developers care about. And they also look to us for some guidance about best practices. So 2013 was the year we decided, OK, we're pulling the plug on Internet Explorer 6. We're just not going to worry about it anymore. So then I would start running my code through Internet Explorer 7 in my head. I take into account that it still has a pretty poor JavaScript engine, slow execution, poor garbage collection, poor debugging. And just the fact that these browsers are, for all intents and purposes, gone now is part of what makes this a special time for JavaScript. So where I'm going with this and why this is a fun talk for me is I'm usually the bearer of bad news. I'm usually the guy who says, yeah, it would be nice if we could use that feature in development, but we have these old versions of Internet Explorer to worry about. And then I explain why we can't have nice things, basically. I'm very choosy about the web standards that I get excited about. I'm very conservative about adopting them. So when a new standard comes down the pipeline, I look at it and I say, OK, but when is this going to be in browsers? So today, my message is you can have nice things. You can have nice things thanks to ECMAScript 2015 and Babel. How many people here use Babel? OK, a few. Yeah, so I'm going to talk about some pretty futuristic seeming things today. But the point is that you can use all of them in production, which is what's pretty exciting. OK, new version of JavaScript, ECMAScript 2015. What does that mean? Well, let's talk a little bit about standards. JavaScript is an industry standard, which means it exists as a document that's written and agreed on by a group of experts from the industry, from different companies and organizations, like the companies that make browsers, Intel, IBM, basically, and also people who are from other organizations or individuals. Here's some standards that I think are good examples of really good industry standards. And you probably have heard of these: JPEG for photos, MPEG for video and audio, Unicode for text. I'm not using web standards in this example because they haven't always been very good, but they've gotten a lot better in the last few years. What impresses me about these other standards is they're very good, and they have to be, because there isn't necessarily one main implementation or even a few. These things have to run everywhere. Your phone actually decodes MPEG video on a chip in the phone. So for that to work, for vendors to do those kinds of things, you really have to have a good spec. And it has to be very precise. And everything just works. You can play videos on your phone. By and large, if it's MPEG, you don't get codec errors. You don't get glitches. It just works. So I would say a good standard is precise. It's exhaustive, meaning it specifies what happens in every case. It's written in terms that are practical to implement. And it accounts for backwards compatibility. It's also really important that there's good process and good leadership behind a standard so that it evolves well with changing times, and so that you get new versions every year or every few years. So we get new versions of standards coming down the pipe. We get emoji in Unicode. We get new versions of MPEG video that are better. So I put JavaScript on this list of good standards. The JavaScript standard is called ECMAScript. These are interchangeable terms these days: JavaScript, ECMAScript. The name of the standard, ECMA 262. ECMA stands for the European Computer Manufacturers Association, by the way. So it's a good standard. It covers not just the syntax of the language, but the entire standard API in every case. In English, it goes on for hundreds of pages. Most of us aren't going to read the spec. I've looked in at parts of it. But having that spec is why JavaScript runs on such a wide range of browsers and devices, and really with very few compatibility issues. It's also why companies like Google, Apple, and Microsoft are able to rewrite their JavaScript engines every few years and make them faster and faster. That would be really hard to do if JavaScript were tied to a particular C code base. Languages like Python and Ruby are more tied to a particular implementation. So it's a great standard. The one problem, the one place where it's been lacking is in process and leadership, which is why we haven't gotten a major new version of JavaScript in a long time. In fact, at this point, we pretty much just expect it to be static. So let's look at some history here. Let's look at why this is. ECMAScript 3, released in 1999, that's the lowest common denominator JavaScript that you have to think about if you're programming for Internet Explorer 8, anything less than 9. ECMAScript 5, on the other hand, is a minor update that was released in 2009. It's got new features like getters and setters, new array methods like for each, and those require Internet Explorer 9 or later or a modern browser. There's more to the story, though. What happened to ECMAScript 4? It got sort of swallowed up in this lost decade. And the history there is that the committee members couldn't agree. You had companies like Microsoft and Mozilla kind of battling it out over what the future of JavaScript should be, what's the next big update to the language. And I was following the story at the time, and I sort of stopped following it. What I didn't realize is the way the story ends is in 2008, the parties come together, people find a way to work together, and we've actually had a good JavaScript committee ever since. So their first order of business was ECMAScript 5 in 2009, and that was just a minor update. And then ever since, they've been working on ECMAScript 6, which is the version of JavaScript where we really get to add a lot of new great stuff to the language that we want. So boom, ECMAScript 6 is on the map, and it was just ratified this year in June. The drafts have been circulating for a while. You might have seen it, heard talks about it as early as last year. It's called ECMAScript 2015 now. They changed the versioning system, sort of like Adobe Creative Cloud, or I don't know. They changed the numbering. So ECMAScript 6 is now rebranded to 2015, and going forward, there's going to be ECMAScript 2016, ECMAScript 2017. And it's really good stuff. It's being implemented in browsers right now. You can already use a lot of this in Chrome, in Firefox, in Microsoft Edge. It might be a little while before it's all there, but there's no holdouts in the browser companies because they all agreed to it. So what's coming in the JavaScript future? I've talked about two trends. I've talked about dying Internet Explorers and JavaScript getting awesome. And they're both at an inflection point right now. They've been moving slowly. They're about to move fast. So one thing I mentioned already, new versions of ECMAScript coming annually. Features appearing in modern browsers more quickly. We've got browsers that are auto-updating now. We've also, because we've got this roadmap now for JavaScript, the browser makers are able to implement features sooner and implement them in parallel with developing the spec. So that's really great. Appearing to the next few years, at some point, we're going to stop worrying about Internet Explorer 8. At some farther out point, I put here as 5 to 10 years, all browsers will be doing the auto-update thing. We're not going to be worrying about Internet Explorer and like who's still running Windows XP. All that was actually sort of a temporary state of affairs basically because Microsoft tied their browser to the operating system. And then finally, and this is the point that I'm going to be selling you on in the rest of my talk, I think what happens now is everybody starts writing ECMAScript 2015 right now and uses a tool like Babel to compile it to a version of JavaScript that works on all these browsers, including Internet Explorer 8. So you can start using this stuff today, and that's what I'm going to explain. But one thing to think about is, if not now, then when? If it's 5 to 10 years before the browsers are all supporting this natively, what happens between now and then? And I think what people have realized is that transpilation answers this question and provides a path going forward. So let's talk about Babel. We've been using Babel at Meteor since earlier this year, and it's been really great. And this talk actually came out of some work I did to investigate Babel, what it does, and whether it's ready for production. So Babel is a transpiler. A transpiler is a source-to-source compiler. It consists of a series of source code transformers. And it takes JavaScript written in ECMAScript 2015 syntax in and produces either ECMAScript 5, or with a little bit of fiddling, it can produce ECMAScript 3. And Babel is written in a modular way so that you can turn on and off the transpilation of different new language features. And you can even write your own. So what are these language features that I'm talking about? Let's look at ECMAScript 3 versus ECMAScript 5 just to get a little bit of context. I've created this grid, and this is sort of what I have in my head when I think about, oh, okay, Internet Explorer 8 supports this, Internet Explorer 9 supports some of this newer stuff. I put them in 3 categories. Syntax, which is basically new syntactic sugar that gets added to the language, libraries and APIs, and then engine features, which are these things that cut really deep into the JavaScript engine. They're new capabilities. They're not things you can fake very effectively. So an example on the syntax front, I won't go through everything on the slide, but for example, the second item under syntax, the fact that you can use keywords as the names of properties and objects, words such as for, class. Some people don't realize you can do this because you weren't always allowed to, but you can now. It just depends on whether you're running Internet Explorer 8 or Internet Explorer 9. So it's something you do have to think about a little bit. Another one is trailing commas. Some people really like this style because if you have a long list over many lines, your git diffs look better because you don't have to add and remove commas. So that was another thing that in 2009 in ECMAScript 5 that was added to the language. Libraries and APIs, you're probably familiar with these. We've got some array methods, object methods. In the engine category, we have getters and setters, which I mentioned, non-enumerable properties, strict mode, and sealing and freezing objects. So if we look at, well, how do we use these things today? And a lot of people are doing this. Basically, everybody does this now. Not necessarily using Babel, but ES5 shim is extremely popular because it lets you use these array methods today, and it lets you use these object methods, function, string. You can actually use Babel to make these syntax features work in old versions of Internet Explorer. It can do this transformation for you. But then, of course, these engine features are sort of in a different category. And the reason that JavaScript frameworks don't make heavy use of these things like getters and setters is that they don't have the browser support. So they're not, you have to be kind of careful how you use these things. You can only use them basically if it's okay if the browser doesn't support them. Now, compare this to what's new in ECMAScript 2015 this year. It's a ton of stuff. I don't have time to talk about all these things. You can read more about some of them online, all of them online. But we've got some really great syntax features like classes, arrow functions, block scope variables. We've got a bunch of new API methods, array methods, string methods, and then some engine features. So given what I said in the previous slide, you can expect that the engine features are going to be, they're going to take the longest time before we can really use them because they're things that browsers have to implement. Old versions of browsers have to die. Time has to pass. So these things are on different clocks. Babel can basically get you all of these syntax features, which I think is pretty amazing. Babel gets you classes. It gets you all these things. And that's partly because Babel's awesome, and it's partly because these features were designed to be basically syntactic sugar. They were designed to be nice syntax on top of what people already do in JavaScript today. Core.js is a library that can get you these libraries and APIs from ECMAScript 2015. And then in the engine category, Babel has a way to do generators, but it's kind of a tricky transform. And Core.js provides a version of Symbol. OK, so I'm going to talk more about a few of these features as examples. But first, let's go back to talking about transpilers, because I said, OK, we can transpile these things. That might sound a little sketchy if you're skeptical about this idea of source-to-source transforms. And I'm a skeptic. I'm very good at generating concerns about things. So let's go through some concerns we might have about transpilers. OK, first of all, they require a build step. You have to run your code through a program before you can run it in your browser. Second of all, what about the performance of the generated code? You're generating this code. Maybe it's bloated. Maybe it has lots of extra functions in it. Maybe it does something slow. The size of the generated code and the runtime that accompanies that code. Does transpilation just blow up your code? Transpiler bugs. Anytime we bring a new compiler into our tool chain, well, compilers are notorious for having bugs, especially if they're new. Transpiler compromises. This is a more subtle point where some features might not be 100% transpilable. There might be trade-offs, or there might be trade-offs for performance reasons. Finally, what about the readability and debuggability of the generated code? Is the code that the transpiler spits out, is it going to be OK, basically, or is it going to be this kind of low-level garbage? So these are all very good concerns. A couple of them we can sort of take off the table right off the bat. The first one about a build step, the ship has sort of sailed on that one. All real JavaScript apps, all sophisticated apps have a build step of some sort, whether you're using React. The solution to that, the build step, is just have really good tools. Tools that watch your files when they change, rebuild your project, tools like Meteor and Webpack and several other tools. Also, the very bottom bullet about readability and debuggability, that's been explored with CoffeeScript. If you've used CoffeeScript or if you've used a transpiler, you've probably seen that the output looks pretty good. And in addition, we have source maps, so you can debug the generated code by looking at your original code. But those other 4 bullets in the middle, performance of the generated code, size of the generated code, transpiler bugs, and transpiler compromises, those are all things to be concerned about in theory. And the way those have been solved is just through a lot of hard work, basically, and through the Babel project maturing and transpilers coming of age. And in fact, the first transpilers were not suitable for wide production use. Even if you just go back a year ago, people were playing with these things. They were sort of a curiosity. We had Google Tracer and a project called 6 to 5, and that was renamed to Babel. And I think Babel has sort of won this war for several reasons. It's more modular, like I talked about. The transforms are broken out into pieces. It also has a really good developer community. It has a really good main developer, Sebastian McKenzie, who's sort of been tirelessly fixing bugs and addressing issues. All the issue threads are very well populated with discussions about these different issues. So I'm here to tell you that Babel is now ready for production. It's a project that's hit maturity. The generated code is small, it's fast, it's readable, and it's compatible. And I'll show you some examples of code and why that's true. The transpilation trade-offs that it makes are well studied, they're well discussed. They're not always well publicized, so that's part of why I'm giving this talk. And I'm not associated with Babel, by the way. I'm just here to tell you about cool stuff. You do have to follow some guidelines when you use Babel. And I'll just go through them quickly. And this is also related to what you'll hear in the field from people using Babel. You should always put Babel in loose mode. If you've ever read people being concerned that Babel code is slow, that's because they weren't putting it in loose mode, which is basically the mode where all the transpilation happens in a way where the generated code is fast, it's compatible. As far as I'm concerned, loose mode is just better for every transform that Babel has. For example, ECMAScript 2015 has a new loop construct for of. Well, you don't want your loop to be compiled in a slow way. So loose mode has optimizations like if it's an array, then just iterate over the array using a normal for loop. And that stuff's really good. Don't put Babel in high compliancy mode, which is, Babel has 3 modes: loose, normal, and high compliancy. High compliancy is like the opposite of loose mode. It makes everything slower, the code bigger, just to satisfy some really, really edge cases. Babel has a lot of transforms to choose from. It has ES2015 transforms. It has experimental transforms that are language features people are still working on and thinking about. So just basically only enable the ones that are actually part of ES2015. Pass them to Babel in a whitelist so that you don't get surprised by Babel adding another transform. This is basically for build reproducibility. Using external helpers. So Babel has some runtime helpers, basically, that help it out. It's a runtime library, but it's very small. It's like a few hundred lines of JavaScript. And Babel has two modes. It has a mode where it puts those helpers in the file with your JavaScript code at the top of the file, which is similar to what the CoffeeScript compiler does, I think. And it has a mode where it uses a single runtime library containing the helpers, and all the generated code just refers to that library. So that's a better mode to put Babel in. Your code's a little bit smaller. You don't have multiple copies of the helpers. Finally, Babel does not support Internet Explorer 8 out of the box. It doesn't claim to. It doesn't cater directly to people who care about Internet Explorer 8. But it's actually not too hard to get to work. So at Meteor, we use Babel in a way that supports Internet Explorer 8. If you use Meteor, you actually get that. And really, if you already test in Internet Explorer 8, you'll find you can just address the issues. It's basically, you just need your own version of the runtime helpers. That's ECMAScript 3 clean. OK, let's talk about what a few of these features actually are. Classes. Classes are really great. You get this new syntax. We sort of have had classes in JavaScript all along. They've just been a little bit hard to use. For example, inheritance, a little bit verbose. Not being able to just call super, kind of a pain. So this is how you would write a class in ECMAScript 2015. We've got a class called textView that extends view. It's got a constructor. Constructor calls the super constructor and sets up a property. And then we also have a render method that calls a super method. So if we take this line by line, you can see where we say extends view, that is equivalent to what we would normally, maybe our framework has some pattern for saying that this one JavaScript class inherits from another. And this replaces that. The constructor just replaces, we would normally just write the constructor as a function text view. The super call you can do in old JavaScript, but you have to call the super class by name, call the constructor by name. There's no comma between these methods, so it's a little lighter on the punctuation. It looks a lot like Java classes in that respect. The render method, normally we would have to assign these methods to the prototype, textView.prototype.render equals function render. So this syntax just makes that a lot easier. Super calls are particularly onerous without this syntax because you have to name the prototype of the superclass in your code. So basically, it's a nice syntactic sugar for what you would do anyway. Another thing that's cool about it is you can omit the constructor, and just like in Java, you'll get a default constructor that just calls super. So if you don't need to write a constructor, then your code is even shorter. And also note that there's no property declarations here. So unlike Java and C++, you can't declare instance fields. You have to set them up in your constructor. So in summary, classes are an example of a great feature that you should just use it. There's no significant performance issues, debuggability issues, or compatibility issues. And in fact, it makes your code more maintainable because it makes it shorter and it makes it obvious that it follows good patterns. Another feature is arrow functions. So this is it's like lambdas in Python. Different languages have something like this. It's a really concise way to write a function expression. So in this first example, we just write the argument to the function, arrow, and then an expression for the function body. So that's basically the square function, just written as x arrow x times x. In this next case, we have two arguments, letter and I, and then the function body, instead of being an expression, is a block of statements. And in this third case, we're just doing a set timeout. So by far the coolest thing about arrow functions is you don't have to worry about the value of this changing. So if you've written a lot of JavaScript, you know that you always have to think about, okay, what's this? And either, in some cases, save it to a variable or call bind on your functions. The great thing about arrow functions is that this always refers to the same thing inside and outside the function. There's no need to bind the function. So when you use these arrow functions in place, you can just keep using this. So arrow functions are great. You should use them. And an example of how Babel works, what Babel does, it doesn't even need to bind your functions. All it does is replace occurrences of this with a variable that it makes up called underscore this. So there's no performance impact. It's just a local variable that the function closes over. Also, when I first saw this, I said, OK, I'm going to fool Babel. I'm going to name my own variable underscore this. And Babel just calls its variable underscore this too. So Babel is smart. It's always aware of what's in scope. It's always aware of how to name things without collisions. And which actually feeds nicely into our next language feature, let and const. So what these are is they're versions of var that give you block-scoped variables. If you've written Java or C++, you're probably used to being able to declare a local variable and knowing that it's only going to be active for that block of code, basically inside those curly braces. Whereas if you have experience with JavaScript, you know that var in JavaScript has a different scoping rule, which is that it's active for the entire function. It's even active before the occurrence of the var declaration. It's active everywhere. And you can only have one var of a particular name in an entire function. So what let and const do is there are new ways to declare variables that give you block scoping. So I've put up an example here where I've tried to recreate sort of a real code scenario. We have this long function called do stuff. At the very beginning, we assign a variable called result. And then we immediately create a function that closes over result. And we pass that function to something that takes callbacks, like an onDestroyed. So what's really nice about this stylistically is that reading the code, we immediately know because of the const, which is like a final var, we know that that result will never be reassigned. So in the rest of this long function, nothing is going to reassign result and then create a bug because that other code that in onDestroyed gets the wrong value of result. And in fact, suppose we skip later down the function, skip over some more code, and we have a loop. And inside that loop, we have another local variable called result. In a language like C++ or Java, this isn't a big deal because this new result is local to that loop. It's local to the block, and it can shadow the other variable named result. It won't just lead to bugs. In JavaScript, when we were using var, this was a problem. These two results would be considered the same, and that would be a problem. When you use let, you don't have this problem because the variable is local to the scope. So the style that people are moving towards now is to always use let and const. People are pretty excited about just not using var anymore. And in fact, the style guide we have, which is based on the Airbnb style guide, is you default to using const. So you make everything const, realizing that most local variables actually don't need to change over the course of a function. And then if there's some reason that a variable needs to be mutable, then you use let for that variable. And you don't ever use var because it has these scoping problems. OK, so here is an even juicier case. This is if you've written a lot of JavaScript code with callbacks and loops where you set up callbacks. You might have even run into this yourself. This is something people run into at a certain point with JavaScript. So we have a loop for I from 0 to 10. inside that loop, we set a timeout that just logs the current number. Or at least we think it's going to log the current number, but then we run the code and we just get 10, 10, 10, 10, 10, 10, 10, 10, 10, 10, and we say, what? Like, how did that happen? And especially if this is more complicated code, we get really confused until we have the insight that there's actually only one variable I. So we have 10 timers, we have 10 functions that we created, but they all point to the same variable I. And this is a really big gotcha with JavaScript. It's unique to JavaScript. It's not something that's the problem in other languages, because other languages have scoping rules that says the loop variable is scoped to the loop. It's actually scoped to the body of the loop. Whereas in JavaScript, you only have one I variable. So this is magically fixed if you just always use let instead of var. In your loop variable, you declare it with let. Let has the proper scoping rules, and your code just works because you have 10 timers, you have 10 functions, and you also have 10 different I variables. So the rule is every time through the loop, you get a new variable I. So this is code that goes into Babel. Babel's a transpiler. It has to spit out code that only contains var that works in all browsers. So what does Babel do? Babel takes the body of the loop and it extracts it into a function. And that function is actually what makes sure that we have 10 different versions of I. It creates a closure, and that closure solves the problem. So now you could look at this code and say, huh, that's interesting, but isn't this going to make all of my loops slow if every loop is now, the body is turned into a function? Well, the cool thing is that Babel only does this if it needs to. Normally, Babel's normal mode of operation is just like take let, replace it with the word var. So there's no performance hit for that. But if Babel sees anything where that doesn't work, for example, if there's two variables that would be in the same var scope, it'll rename the variables. If it sees you closing over a loop variable from a function, it will just create this function for you. And I don't show it here, but you can even break from loops. You can continue from loops. And Babel will compile it in such a way that it works. And there's no edge cases left, basically. All the different cases here of closing over a loop, Babel can handle. If anything, this stuff is the edge case. This is the stuff that Babel gets right. And that's why it's great. OK, one more feature I'm going to talk about that's new in ECMAScript 2015. This is module syntax. So ECMAScript 2015 doesn't specify how modules are loaded, how modules are distributed. What it does do, actually I'll go to this slide first. What it does do is it gives you a new syntax, which if you're used to Node syntax, CommonJS, it's pretty directly transpilable to that. So you can now write import foo, bar from some module. And this will put the names foo and bar in your namespace. It works sort of like Python's import, just to pick an example. You can also say import star. There's just really nice syntax around importing. And you also get syntax for exporting. So you can export a function. You can export a class. And then in the bottom right, that's what this transpiles to. So that's basically what it's sugar for. For exports, you assign to exports.log foo. For imports, there's one interesting thing here, which is that all the occurrences of foo and bar in the original code are replaced with mymodule.foo and mymodule.bar. And the reason it does that is to get the semantics from ECMAScript 2015 about modules that require each other with circular dependencies. So if you've written modules in Node, or you've had modules require other modules, you get this case where A requires B requires A, and the only way that can be resolved is for Node to basically give one module a version of another module that's not completely initialized. So the case where this comes up is we're importing from my module. What if my module just imported us? What if my module imported this file, then this file goes to import my module. So it's a circular dependency. The way that's resolved is it'll get an object back, but it's not yet populated with all the names on my module because the code hasn't run yet for my module. So transpiling this way helps the situation because it doesn't matter. It doesn't matter that my module hasn't quite been initialized yet. It'll still work because the code that references foo also references the module object. So let's look back at all these features, which I don't have time to talk about all of them. They're cool. We use them in production at Meteor. And the more I've looked into these, the more impressed I've been by what the language designers have done. It's a balance between incremental changes that reflect things that are already happening, like promises, but it's some major new syntax that really provides some big benefits. So I think transpilation is actually going to be around for a while because browsers aren't going to support this stuff natively for a while. And here's a quote I came across online that I think really captures the spirit of this. I can't see a time where we won't run our code through something like Babel, because by the time ES2015 is fully implemented, the next version of the language will be well underway. In fact, this is a good thing because it should let new proposed features be tested by developers before they're implemented. The feedback loop should be quicker as a result of people writing ES7 way before release, and that can only benefit everyone involved. So that was written in May. And that's what was already happening, actually, and what's still happening. We have this synergy between browsers, standards, and transpilers. So people implement a feature as a transformation in Babel, and then the browsers might implement it behind a feature flag that says it's experimental. It gets moved through the standards process, and all this stuff happens in the community with a lot of transparency now and a lot of discussion. And it's just really, it's exciting, and it's an exciting time for JavaScript. So in conclusion, we've just entered a new age of JavaScript, and you can use Babel and ECMAScript 2015 today, and I think you should. I've looked into it, and it's a sound engineering decision. We use it in production, and we're really happy with it. Thank you. Looks like I finished a little early. So are there any questions? Yes?
What features you tried that you would not recommend using?
The question was, what features would I not recommend using? By and large, I think it's the engine features like generators and some of this stuff like proxy and reflect. Yeah, I wanted to come up with more examples of things you shouldn't use, but it's actually kind of hard to do. Yeah, I think the stuff we've only just started experimenting with is iterators and map and set, because they require runtime libraries. So the more of core.js you pull in, the more of a runtime library you have. So that's one concern is, you might want to pick and choose your features rather than just saying, I'm going to pull in all of core.js. But that's really the main thing. Yes?
You alluded to the memory mapping between the source and then compiled down JavaScript. I just wanted to make sure I understood this. If I'm in Firebug then, and I'm looking at ECMAScript 6 code and setting breakpoints there, and I just don't have to see what's underneath it?
Yeah. Yeah, the question was, for source maps, does it just work if you go into your dev tools, do you just see the ECMAScript 2015 code you wrote? And yeah, the answer is yes. Babel has good source map support. So as long as you've got it wired up to your browser, you can debug and see your ECMAScript 2015.
Well, that's what I was kind of getting to. I understand it generates some maps, but does Firebug just kind of know how to get it, or do you have to do a new plugin, or is there a conflict afterward? Is that part?
Do you mean how do you configure it?
Well, it's the source mapping.
Yeah, the result is that in the debugger you see the original code. You can view both actually. If you turn the source map off, you see the transpiled code. But yeah, it pretty much just works. You can even inspect variables. There are some cases where if Babel renames your local variables, the debugger might not show the right tooltip or something, but Babel tries to preserve all the variable names for exactly that reason, and to do unobtrusive transformations. Yeah, works well. Yes?
So speaking of debugging, have you had any good luck with integrated development environments and debugging? Have you been able to, through source mapping, plug that into the IDE and get any meaningful output or interaction?
What sorts of IDEs are you talking about?
Visual Studio, IntelliJ IDEA, hate to mention it, Eclipse.
The question was, do source maps work with IDEs, basically?
As far as debugging, actually stepping through the program.
As far as debugging. I believe so. I don't use an IDE in my daily development, but the Chrome debugger works really well. And the Node debugger works well. So that leads me to believe. Also, source maps have been around for a while. They're a couple years old now. They were pretty hard to use at first, but I think the tooling is there now. They've gone through a couple of versions. So I would expect that using an IDE with source maps, that would just work. And I mean, yeah, because stepping in the debugger in Chrome works. You can step from line to line, step around loops. Yeah. Other questions? Yes?
So I think you said that the latest Chrome actually supports ES2015, is that right?
It supports a lot of stuff. It doesn't support all of it.
Okay, so like in the future, right, when something actually does support ES2015, would you output both, or would you just like copy over the code for the one version, and is there like detection to know if ES2015 is supported? Does that question make sense?
Yeah, I think so. Is the question that
Like
once browsers support this, will we then start showing the original code to those browsers? Yeah, I think so. One concern is that it's just simpler to show the same code to all the browsers rather than to transpile it for some and not for others. Also, the feature detection might be a little hard to do, given that some features are implemented and some features aren't. There also are a few nuances around using the native versions of these features together with the transpiled versions in a tightly coupled way. And there's also, people are experimenting with features from ECMAScript 2016, like decorators. So in order to use those, you end up transpiling, for example, classes for all platforms anyway, because otherwise there's no way to use decorators. For example, Angular uses decorators, which are imported from the farther future. So I think at least for a while we're going to be transpiling, and then we can look again in a few years and say, do we still have to be transpiling? On the server side with Node, I mean, at Meteor, we think about universal JavaScript and running, the same code everywhere. But if you're just writing server-side Node code, you might not have to transpile if it supports all the features you want. Let's see, which ones of these are implemented now? Like in Chrome, I think you can use classes, arrow functions. Yeah, some of these are there, some of them aren't. Interestingly, proper tail calls is not implemented in any browsers, but it's part of the spec, so we should see that at some point. Other questions? Yes?
You mentioned briefly IDA.
Mm-hmm.
You said it was doable with custom helpers, which seems a little scary. I'm wondering if you just go a little bit more into that. What are the gotchas? What subset would you focus on first? How would you actually go about doing it?
When you say focus on first, do you mean particular to IE8 or in general?
Support IE8 or need to support IE8. How would you suggest going about it? What's the subset? What are the gotchas? And
Okay.
how would you go about it as custom?
Yeah, the question is dig into the Internet Explorer 8 support in a little more detail and how you go about that, what the gotchas are. So, yeah, So Babel started as 6.5, so originally they just said it's out of scope to even target ECMAScript 3. What we found, though, was the reasons that the helpers don't work in Internet Explorer 8 is just stuff like they use object.create, object.define property. For example, when compiling classes and attaching methods to classes, Babel would use object.define property, but not really for any good reason. So what we did was we wrote our own versions of the helpers. And I think, yeah, you can look at what we've done in Meteor. If you want to talk to me about that or get in touch with me, I can point you towards what we did. But I started with classes and just said, OK, what helpers does Babel use for classes? And it's like 2 or 3. And then arrow functions. This is pretty much the order we went in, I think. And it was just a process of making sure each feature was OK, which is something you kind of want to do anyway, because if you have a team of developers and you're going to change to a new style, you say, OK, now we're going to all write classes. Well, what's our style for that? And what are the implications for that? What are the browser compatibility implications? And part of what Meteor does is it tries to take care of that for you, because if you use Meteor and you say, I want to use a transpiler, then we make it just work in Internet Explorer 8. But obviously, you might not be using Meteor and still be interested in that. And yeah, it's just a matter of basically going through the helpers used by each feature. There really aren't any that are particularly difficult. It's just that the features weren't written with Internet Explorer 8 in mind. OK, we're out of time. Thank you very much.